So right now, we don't have any collisions in our game. So let me add a cube to our scene so that we can test collisions. Okay, let me just make this cube a little bigger. All right, so now if we try walking through this cube, you can see that we don't have any collisions. So we need to handle that. So to handle collisions, we have two options. We can either use a rigid body or we can use a character controller. So for this project, I'm going to use a character controller. So let's look at the documentation of the character controller to understand what it does. So in the docs, you can see that the character controller allows movement constrained by collisions, and it is not affected by any external forces. So this is an important point. If we are using a rigid body, it will be affected by external forces. So we don't want that for the player in our game. That can cause problems in the future. So we are going to go with a character controller instead of rigid body. All right, so let's go back to Unity and let's add a character controller to our player game object. So let me search for character controller. All right, so now in the scene view, you can see that there is a capsule collider. So the character controller comes with a collider, and we can adjust the size of the collider by changing these values. So I'll change the height to something like 1.7 since that's the height of our character. So next we need to add an offset in the Y so that the collider fits the height of the character. So usually I like to set the Y a little above the half of the height. So the half of the height is 0.85. So I'll increase it a little and make it 0.9. All right. So this will make sure to keep the player's feet grounded. So next, we don't want the radius of the collider to be this big. So I'll set it to something small like 0.2. Okay. And one more thing I like to do is I like to add a little Z offset somewhere around 0.08. So the reason for this is because our player will always face the direction in which it is moving. So collisions will mostly happen in the front side of the player. So I like to offset the collider towards the front side. All right. So we have set up the character controller. So next, when moving the player from the player controller script, we should not move it directly by updating the player's position. Instead, we should use a move function of the character controller. So that will make sure to constrain the movement by collisions. So we should use character controller.move function instead of this. So first, let's get a reference to the character controller. All right, I'll cache a reference to it from the awake function. Okay, so now to move the character, I'll use character controller dot move function. And for the motion vector, we can pass the same value as before. So let me just cut that and paste it over here. All right, and I can get rid of this line. So this will move the character just like before, but it'll also constrain the movement by collisions. So now let's go to Unity and test if the collisions are working. Okay, so now you can see that we can run to the cube. All right, so the collisions are working fine. So next, we should handle gravity and make the player fall when the player is in the air. So right now, if we place the player in the air and if we run the game, you can see that the player is not affected by the gravity and she can basically walk in the air. All right. So the character controller is not affected by any forces like the gravity. So we have to manually apply the gravity to our player from the player controller script. So to apply the gravity and make the player fall, first we should check if the player is in the ground or is in the air, right? We should only make the player fall if the player is in the air. So the character controller has a field to check if the player is standing on the ground or not. So the name of the field is grounded. So this will return true if the character is standing on the ground. But the thing is, I find this field of the character controller to be really buggy. Sometimes it can return wrong values. So I don't like using this. I like to manually check if the player is in the ground or not by using physics. So if you look at the implementation of the third person controller in Unity's starter assets, you'll see that even in this project, they are not using the is grounded property of the character controller. Instead, they are checking it manually by using physics. So let's also check that manually by using physics. So let me get rid of this line. All right. And below the update function, I'll create a new function called ground check. So from this function, I'll use the physics dot check sphere function to create a small sphere at the player's feet and check if there are any colliders overlapping in that sphere. Okay, so here you can see the description of this function. It will return true if there are any colliders overlapping in the sphere that we defined. Okay, so to create the sphere, we have to pass few things. We have to pass the position, the radius, and a layer mask. The layer mask is optional, but it's really important to use a layer mask when you're doing any physics operations. It'll make the operation a lot more efficient. If we provide a layer mask, then this function will only check for colliders in that layer. Okay, so I'll define serialized field variables for these three values so that we can control them from the inspector. All right, so first let me define a variable for the radius of the sphere. So I'll call this ground check radius. Okay, I'll set it to something like 0.2 by default. So next, for the position, we don't need a separate variable for the position. We'll be using the position of the player itself, but it would be nice to add an offset to the position. So I'll create a vector for the position offset. All right, let me call this ground check offset. So next, we also need to define a variable for the layer mask that we need to check. So I'll create a layer mask over here and I'll just call it ground layer. Okay, so now in the check sphere function for the position, we can pass transform dot position, but we also need to add the offset, right? So what we can do is we can transform the offset point based on the player's current position. So we have a function for that called transform point. So what this will do is this will transform the position from the local space to the world space, and it will transform it relative to the transform that we are using here. Okay, so in this case, it will transform it related to the player. So I'll call transform point, and for the point, I'll pass the ground check offset. Okay, so we have passed the position. So next, let's pass the radius. All right, and finally, we'll also pass the ground layer. Okay, so this will check if the player is standing on the ground or not. So let's actually create a variable to store the value of this function. So here I'll create a Boolean variable called is grounded. Okay, and I'll store the value returned by this function into the is grounded variable. All right, so now all we have to do is call the ground check function from here, and after that we'll know if the player is grounded or not from the is grounded variable. Okay, so let's actually use a debug.log so that we can test if the player is grounded or not. Okay, so next I'd like to visually see the spear in the scene. So this will allow us to set the offset and radius properly. And also if there are any issues with the ground check, it will allow us to understand what's happening. So we can achieve that by drawing a gizmo. So gizmos are the shape that you see in the scene. So for example, if you select the player, you can see the collider. So that's actually a gizmo. So we can draw a gizmo like that for the ground check spear. So to draw a gizmo, we can do that from two functions. The first one is on draw gizmos, and the second one is on draw gizmos selected. So on draw gizmos selected will only draw the gizmos if this game object is currently selected. So let's use that. So we can draw a gizmo by calling gizmos dot draw spear function. All right. So for the center, we can pass the player's position offset by the ground check offset. And for the radius, we can pass the ground check radius. Okay, so this will draw the gizmo. So we can also specify the color of the gizmo by setting the color before the draw function. So I'll set gizmos.color. So I want the color to be something like a green. So in the RGB value of the color, I'll pass 0 for red, 1 for green, and 0 for blue. Okay, and I'll also pass 0.5 for the alpha because I want the spear to be a little bit transparent. All right, so now it should draw the ground check spear when we select the player in the scene. Okay, so you can see that it's drawing the ground check spear. So let's adjust these values. 0.2 is okay for the ground check radius, and for the ground check offset, I like to put the y value at half of the radius, so I'll make it 0.1. All right, and I also like to give a little bit of offset in the z so that the spear covers the feet. So around 0.07 should be fine. All right, so now the spear covers the feet of the player. So next we need to assign the ground layer. So what I'll do is I'll add a new layer called obstacles. So all the obstacles like the ground and this cube over here, all those will be in the obstacles layer. All right, so let's go assign the plane to the obstacles layer, and I'll also assign this cube. Okay, so now for the ground layer, we can just pass the obstacles layer. All right, so that's all we have to do. So let's go ahead and check if the ground check is working. All right, so right now, since the player is in the air, you can see that the is grounded value is false. But if I go to the scene view and bring the player down to the ground, you can see that it becomes true. So our ground check is working properly. So now we know if the player is grounded or not. So next, if the player is not grounded, we should apply the gravity and make the player fall, right? So what we have to do is, to the move function of the character controller, we should also pass the vertical movement of the player. All right. So if the player is grounded, there won't be any vertical movement, and otherwise, we should apply a vertical movement to make the player fall down. Okay. So the first thing I'll do is I'll move this line out of this if condition. The reason is because the vertical movement should happen even if we are not pressing any input for the movement, right? Even if we are not pressing any keys, the player should fall down. So I'll move it outside the if condition. And then what I'll do is I'll put the movement vector in another variable called velocity. So let me define velocity over here. All right. And then we can use the velocity variable over here. So now we can also set the y component of the velocity if the player is falling, right? So if the player is not grounded, then we can apply a velocity over here to make the player fall down. And by the way, guys, if you don't know what velocity is just the speed of something at a certain direction. All right. So if you say a car is moving at 40 kilometers per hour, that's a speed. But if you say it's moving at 40 kilometers per hour in this specific direction, then that is the velocity. So it's just a speed with the direction. All right. So we have to set the y component of the velocity to make the player fall. So if you know how gravity works, you'll know that when something falls, it will not fall at a constant speed, right? Instead, its speed will keep increasing throughout the fall. So to be more accurate, every second, the speed of the object will increase by the gravity. So we can't set a constant value here for the y velocity. We need to keep increasing it. So what I'll do is I'll create a new variable to keep track of the y speed. So let me create a float variable called y speed. All right. And then if the player is falling, then we should keep increasing the y speed by the gravity, right? So if the player is grounded, we don't want to do anything now. We want to increase it if the player is falling, right? So we want to increase it from the else part of this condition. Okay. So if the player is falling, then we should add gravity to the y speed. So we can get the gravity in our game by using the physics.gravity property. And we only want the y component of the gravity. So I'll just get the y. So this value is actually set from the project settings. So if you go to edit and select the project settings, in physics, you can see that we have gravity. So this is where the gravity of the game world is set. All right. So here, if the player is falling, we want to increase the y speed by the gravity, but we should also multiply this with time.delta time. So this is because the y speed should increase by the amount of gravity every 1 second, right? But the update function is not called every 1 second. It's called multiple times in a second, right? So we have to make sure to multiply the gravity by the delta time, which is nothing but the value that has passed since the last frame. So now we are increasing the y speed if the player is not grounded. So let's set the y speed to the y component of our velocity. All right. And then if the player reaches the ground and his grounded value becomes true, then we should reset the Y speed back to 0, right? But what I'll do is, instead of resetting it back to 0, I'll reset it to a small value like minus 0.5. So the small value will make sure to stick the character controller to the ground. All right. So this should make the player fall down if the player is not in the ground. So let me just get rid of the debug log, and let's go ahead and test if the player is falling. All right. So you can see that the player fell down. So the gravity was applied correctly. So let me also try placing the player over this box just to test how it falls from such objects. All right. So first we'll fall to the box and we can move from here. But if we move past the ledge of the box, then the player will fall towards the ground. Okay. So if that's not working for you, there are a few things that you have to check. So the first thing to check is the value of the ground check radius and the radius of the character controller should be almost same. So if you make the character controller radius a higher value, then you'll have a bug where the ground detection will not detect any ground. But since the character controller is bigger, it won't allow the player to fall down. All right, so that's one thing to keep in mind. The radius and the Z offset of the ground check sphere and the character controller should be similar. They don't have to be exact same, but they should be in the same range. All right. So next, I just want to organize the player controller inspector a little. So I want some segregation between the speed variables and the ground check variables. So we can easily do that by adding a header above the ground check variables. So let me add the header attribute, and I'll just call this ground check settings. Okay. So now there should be some segregation between the variables in the inspector. Okay. So yeah, we have handled collisions and gravity in this video. All right. But right now, the player can still move and play the walk animation when she's falling. We'll be fixing those in the future. But right now, this is a good start. So next, let's set the skin width property of the character controller. So this is a really important property. So if you go to the documentation of the character controller and if you switch to the manual, so the manual will have more detailed explanation when compared to the scripting API. So here we have a detailed explanation of all the properties. So if you look at the skin width allows other colliders to penetrate the character controller a little. So this is used to reduce jitter, and it also prevents the character from getting stuck. So Unity recommends setting this to 10% of our radius. So in our case, the radius is 0.2. So the 10% of 0.2 will be 0.02. All right. So I'll set the skin width to 0.02. So next, we should change the Y of the center based on the value of the skin width. So earlier I told you that the Y should be a little above the half of the height for the character's feet to be on the ground. So if you want to be more accurate, we can set the center to half of the height plus the skin width. All right. So half of the height is 0.85 and the skin width is 0.02. So if we add that, we'll get 0.087. So this will place the feet of the player on the ground perfectly. So let's go ahead and test to make sure that it's working fine. All right. So you can see that the feet is planted on the ground perfectly. Okay. So I'll stop the video here, and in the next video, we'll add controller input so that we can control our player with the joystick.